Okay, another concept about how species start to originate is called coevolution. Now, this is a little different than macroevolution, where we have a geographic separation. Coevolution is when two species evolve together. And so it's a symbiotic relationship between these species. It could be a mutualistic relationship where both of them are benefiting, a commensalistic relationship where one benefits and one does not. But typically it's a parasitic relationship where you're going to see a parasite and a host. We typically see it with flowers and pollinators. We'll see it with predator-prey relationships. These are the most common. So basically what happens as one, say, host, gets an immunity to a parasite, the parasite is no longer able to live in that host. So it has to change or evolve so that it can stay in its host species. If it doesn't change or evolve, its food source is gone, it becomes extinct. Coevolution also helps to describe the endosymbiotic theory. Now remember, with the endosymbiotic theory, we basically had a large single-celled prokaryote engulf a smaller single-celled prokaryote. Those two prokaryotes started to live together, co-evolve together, and became what we think is the first eukaryotic cell. Now, why do we think that? Well, remember that the mitochondria and the chloroplast have different DNA sequences than the nucleus, which means there has to be some differentiation there. There has to be some difference, a reason why we have that. And so with coevolution, it kind of explains that. Now, remember, you don't have to have a geographic separation with coevolution. You just have to simply have two species interacting with one another. And most of the time, again, we're going to see that in our parasites and hosts, our predator-prey, or flowers and pollinators, because they're going to evolve. Defenses will be evolved by the host or the prey, and then the predator has to change, or the predator or parasite will have to die. Okay, so now we talk about, again, macroevolution. It comes up a lot. There's a reason for it. It's kind of important. But we're going to talk about some concepts with here. So one of the macroevolution is the tempo of the species can appear to jump, be steady or jumpy. It has no real reason why. So let's talk about gradualism model. A new species in a gradualism model will gradually accumulate changes over a long period of time by natural selection. And remember, natural selection, the strong will survive and reproduce. And so with gradualism, they're typically stable conditions. And this is how Darwin thought that most species were evolved, was because of gradualism. And then we have a punctuated equilibrium. This model draws specifically from the fossil record. And so we can see that this changed a little bit from the diagram on the last page, where you just saw this two branches and steadily increase. This phylogenetic tree is a little bit different. Species are able to change, and most arise from a common ancestor. However, the changes are not always steady, and there's not always a specific common path for them. And so with punctuated equilibrium, this is based on geological and climate conditions are changing for this. Evolution may occur more quickly during this. They're typically during long periods where there may be no change or no differentiation within the species, and then you have an interrupted burst of complete rapid change occurring. Most models for this, the timing of evolution, will show this punctuated equilibrium. And this is what best supports the fossil record and is more commonly accepted than gradualism. Nobody believes things just change steadily over time without any disruptance in them.